Alright, I was down here last night and I cleaned the gearbox and the parts washer, and tonight I'm going to make a new gasket for the lid. I've got two types of gasket material here in my shop. I've got this cork material, which this section here is not wide enough, but it looks like if I wanted to I could probably squeeze a gasket out of this section right here. But I think I'm going to save my cork material and go with this material here. This is another type of gasket material I picked up. I think I got this at Napa. I think this is going to be good enough for my application here. So, give you a look at the box. So here's what the inside of the box looks like once it's cleaned up. It's actually got a red paint coating on the inside there. Yeah, cleaned up pretty well. I'm satisfied with that. Certainly better than what it was. So there's a couple ways I could go about making the gasket that fits this. One of the problems is, one of the thoughts was I could use the lid. I figured the lid was going to be easier to work with just because it's lighter, but I actually decided not to do that because upon examining the lid, I could see the lid has these really wide areas right here, and they are nowhere near the size of these areas on the bottom. So if I made a gasket using this as a pattern, I would have these strange shaped bowed out areas on the corners and on here. So I want to make the gasket to this size. So one of the things you can do is you can actually hold the gasket material on here, and you can actually take a small hammer and you can tap around and you can actually make an indentation into the paper lots of times just by doing this. Just take a look and see how well that works. Essentially what I'm doing here is I'm using the sharp edge of the metal case to cut me a nice shape, and that seems to be working out fine for the outside edge. That's not really doing much for me on the inside, though. The problem is that you gotta worry about it moving on you. That happens. I think I'll start cutting this though. I've got a good outline here now on this end. So what I can do is I can cut along the outline that I see, and what that's going to do for me is then I can just hold that to the edge. It'll help keep it lined up. Alright, that looks pretty good so far. I'm going to use this flat plate to help hold this thing in position because the way it's curling. Now to get the alignment of the holes right, I'm going to just use a pencil and try and see if I can't get that edge to darken up a little more. That's a pretty good circle. Now let's see if I got a cutter that size. Alright, this is all of them. That's obviously too big. Yeah, I'm glad I used that tiny bit larger punch. That lets me move this around a little bit if I don't have the alignment perfect. Alrighty, not sure why the camera shut off. Sometimes it does that. Battery looks healthy, so must have just went too long with that video. Anyways, I finished cutting the holes. Alignment looks pretty good. Not perfect, not going to win any awards, but should be perfectly fine for this application, considering that we're not dealing with a lot of pressure here. This thing's not going to be filled up more than about up to here with oil. So most of what would leak out of the top here would be splash while it's running. So I think we'll be okay. Alright, so now that I got my gasket made, I can set that aside. I can start reassembling the box here. I'm going to have to do some trial and error here and figure out how we're going to handle the setting the end play and setting the clearance on these bearings. I'm going to do this in reverse order. So this is the input shaft went in here, and I think that's the first shaft I'm going to put back in. So these are the two bearing cups or races, and I made sure that I kept the oh, I was wrong, the battery is dying. Well, anyways, almost all of these shims except for two measured just about 10 thousandths. Good morning, everybody. It's another Sunday morning. It's been a couple days since I've been down here working on the front gearbox. I ended up finding out a little bit more information about how you adjust the bearings. Apparently this type of bearing, it's pretty common the way they do this setup, where they have a fixed inner cone of the bearing on the shaft, and then the outer cone, or what I call the race there, is able to be moved in and out. And oftentimes on gearboxes they'll have a plate just like on mine, and the plate is shimmed to control how far in that outer cone is pushed onto the actual rollers. So that was great that I figured out, yeah, okay, I'm on the right track here. Obviously these are shims. Obviously, you know, this has to be shimmed correctly. Unfortunately though, the information I got that from was the Timken Bearing Company, and they basically say that you're supposed to go to the manufacturer and get that information as far as what that clearance should be, because that it's going to be different depending on application and different things. So unfortunately, the only way I'm going to get that information is through the Turner Unidrive company, and they are still in business, but I haven't had a chance to contact them and try and get that information, and I really want to get this done. So last time I was down here the battery died, but I played around with it, and I've got one of the shafts in there, and I've got it set to what I think is an okay clearance. That's weird, my camera shut off. Alright, well, anyways, so I took out that one shim, and now this spins nice and freely. It's not bound up any at all, but I still don't have, well, there it is. You can just hear that little click there telling me that I've got a perceptible movement of the shaft here. So I think that's okay. I hope so. Now I'm just going to install the new seal in this cover, and this cover doesn't have a, there's no ridge or anything in there to stop this seal from being able to go in further. So I don't really have a guide as to where this seal should be positioned. What I'm going to end up doing in this particular application is I'm just going to install it so that this front face of the seal is flush with this front edge here, because that's how the seals were that I took out. The only thing that bothers me about that is that this is the original seal, and this seal crossed to this seal, and this seal is a different design because it's so wide, and it has a shielded area on the back
This is more like a conventional seal. Let me get some better light on this. Those of you who may not be familiar with oil seals. Alright, so the part number off of here is a good national part number, and it was readily crossed to a replacement. These are SKF seals, and so it's a good quality seal. That's nice. But what's interesting is you look at it, look at the side dimension difference. Okay, you look at you know, the bore is the same. Believe it or not, it doesn't look it, but it is. And the OD is the same. So it's a good match there. But the weird thing is, this is a typical oil seal the way it's designed. Typically this is the side that faces out, and then your fluid side is going to be on this side. And what you got is, you've got this rubber lip that hugs the shaft, and there is a spring that is a circle that goes around the outside of this, and that actually gives it spring tension and keeps that rubber up against that shaft while it's running. And then this is all hollow right here. So what they did on this seal, for some reason, is it's almost like a fully shielded bearing. They've got this metal piece that they pushed in on the backside there to completely hide this opening. And I don't know why they did it this way, but I looked on the internet and I couldn't find any seals that were like this. Now, I guess I could have taken the bore diameters and sourced the seal that way, and maybe if I looked specifically for this kind of seal, but I just don't think for this application that I need this thing. I think this will do just fine. The only thing that's going to get in here from the back side is an oil splash, and that wouldn't be much different than an application on a motor or something like that. So, well, you know, so it is what it is. But it's funny that this crosses to this, but it did. Huh. Wow, that Dake arbor press. Boy, I'm thrilled with the purchase of that item. You know, again, like I said before, I got that big, well, not really big, but I've got that hydraulic shock press from Harbor Freight, and that's great, you know, and I've used it in the past for driving up bearings and things, but boy, for something like this, that arbor press just makes this a snap. You know, I just put myself a nice big spacer on here so that I'm, you know, putting force evenly on this outer ring, and it goes right in. Alright, so now that feels a little bit stiffer, but that's actually the tension of the rubber seal on that shaft. Alright, so I'm going to call the installation of shaft number 1 done. So now I'm going to do 2 and 3, but I'm not going to do that on camera because I've only got about an hour at the most probably left this morning before breakfast, and then the rest of the day begins. So if I don't have to worry about camera position and all that, I can do things a lot more quicker. So hopefully next time I turn this on, you'll see 3 shafts in with the new seals, and we'll go to the next step, which is going to be the shifting mechanisms. You know, it occurs to me that I had forgotten to take out the seal, so I was trying to bang it out from the backside the other day, and it's actually, the seals are in there so tight that this screwdriver actually bent out the lip there. I'll try it one more time before I decide to switch to something different. Ah, there we go. Now I know this box is going to be too tall to stand up in the arbor press, and I really don't feel like going through the trouble of bringing this all the way, setting up the plates and everything on the hydraulic press. So I think what I'm going to do is
Just cheat a little bit on this one. Alright, go get the shifting dogs and other parts. Oh, the other thing I did since the last time I was down here running the video on this project was I took all of these caps back off and I put a thin film of black RTV sealant on them before I put them, and then put them back on and tighten them up again for the final time. And hopefully that thin film of RTV isn't going to really change much as far as the clearance goes. The reason why I did that was because I noticed that those plastic shims weren't doing a very good job as gaskets from keeping even the little bit of oil that I had squirted in from the backside from leaking out. So hopefully, you know, I'm trying to keep this thing from becoming a huge mess, because this thing was just so dirty from leaking oil and having the dirt stick to the oil on the outside of it. With it all cleaned up, I'll be able to, you know, hopefully spot any leaks and address them fairly quickly. But I'd like to try and avoid them altogether. So anyways, next bit of business is putting these in. And this is kind of like I can either go and look at my videos, or I can just figure this out through kind of like jigsaw logic. I had the boys down here the other day and I was showing them how this worked inside and how the smaller gears to a larger gear change. I was trying to teach them a little bit about gear ratios without getting too advanced, just giving them an idea how this gearbox worked. And so I had brought this over, so I know that this is the first one that I had cleaned and put off to the side. So I know that this is the one that goes up in the front here, because I took this front one out first. So I know that this bar has to go in here, okay, but the question is which way. It's also this, so we're going to play around with this a little bit. So the first thing I'm going to do is I'm going to look at this and I'm going to see that the wear marks on here are deeper or wider. There's a wider band of wear on here than there is on this side. And I know this is going to engage this gear cluster right, this gear cluster right here. So this narrower band has to be on this side here, because it's just going to go up against this little sleeve. So this has to go on like this. So I know this is going to go on like this. So that's the first clue. So I know this has to stay in that position there. I know it has to go in this way. I know that the little ball bearing that rides and snaps into these little holes, right now it's facing up. So I know this is going to have to go in like this. So the last thing I need to figure out is whether this goes in this way or it goes in this way. Well, notice we've got this stop screw here, and this little ball bearing hole right here is very close to the stop screw. So if I put this in this way, then this should be able to slide over here just far enough for that last ball bearing to click in. As opposed to if I put it in, if I flip this around, like I was considering doing, if I put it in this way, well then the problem is there's no way this rod can travel through, this could travel down far enough for that to ever even engage this third hole. So that seems like a no-brainer, except for one thing. I can't necessarily just assume that that's the case, because there's 3 indentations, but I think this front lever only has 2 positions. Now, the top lever only has 2 positions, right and left. the front lever looks like it has 3 positions. Well, let's see. I can figure this out easy enough. That's position 1. Well, actually, each one of these only has 2 positions. Yeah, that's... Oh, wait a minute. Okay. I think I know what I'm doing wrong here. That's position 1. That's position 2. And this doesn't go out that way. Alright, so this is only going to travel from here to here. So the furthest that's going to go over to that way is right there. I know that this has to go on like this. I know this has to go with the bumps facing down. Didn't I have to take this screw out to get this out? Oh, maybe I just put the screw in temporarily on the wrong side. Oh. Alright, decided to do the back one first. I don't know why, but it just seems easier to figure out. So what I did was I looked at this shifter, which I know is for the rear, and this has got a wider wear band on it on this side than this side, so I know this is the side that's going to be up against this larger gear. On this one, I know that this has to face up because that fork is actually comes over to the top lever. So this has to go like this. Now, because there's a little grub screw on the back side of where the spring and ball are for the little ball that goes into the little detents to positively lock it into position, I can actually look down and see that that ball is right here. Okay. So if I temporarily take my bar, which I know this is the bar for the rear, okay, and I look at it, I know. First of all, I know these have to be facing up, obviously, because the I'm sorry, they have to be facing back because the ball comes in from the side on this back one. Well, you're not going to be able to see that on the video, but trust me, it's there. Okay, so I know this is going to go like this. And then if I line up this gear into the first one of the 2 positions, and I hold this bar across like this, I can see that there's a detent right here that's lining up with it right now. So right about there. Okay, and then if I shift it all the way over here, well, right there is the middle position, which that must be neutral. And then over here is going to be, this will be the other position. So the detent will be right about there. Alright, so I know that this is how this one goes in. So I guess those screws did actually have to go. I mean, the screw has to obviously go in after I put the bar through. Alright, well, I'm not going to pull it back out at this point. What I'm going to do is I'm going to put a little film of grease on there. Now when I tighten these nuts, I can loosen one nut and tighten the other one a little more, or vice versa, to shift this bar back and forth the slightest bit so that I can get perfect alignment when it's in the correct position. So right there it must be in the center detent. Alright, I just popped it on and I just popped it back in again, and to make matters worse, I use this I don't know why I need to use this stupid plastic mallet. But I just saw a little chip go flying. little chip of plastic. Hopefully it didn't end up in the gearbox. Go through all the trouble cleaning this thing out, putting clean oil in it, getting ready to put clean oil in it. I hate to have a hunk of plastic in there. Alright. So then, screw. Alright, so now this screw goes in here. This screw must have went in from this side. Why do I think that? Well, because I don't remember having a real hard time getting this screw out, and it would be kind of tough to get that. It'd be kind of close quarters there. Really, from what nearest I could tell, the purpose of this screw is just to limit the travel of this thing this way. Alright, so now let's tackle this other one. So I'm going to go ahead and take this screw right out. And again, the wider wear mark is going to be on this side. So I know this is going to have to go on like this. This one, this faces this way, because this lever actually goes like this. The fork type lever that grabs this goes like this. Now if I do that, then the indentations have to face down on this one. So again, if I look at my, that's one position meshing. It doesn't go over that way, and then the other position meshing is over here. If I put my bar on top, temporarily line it up and eyeball it, I can see that if I put it in this way, the ball's going to be in this indentation now. And if I shift it over to this side, then the ball's going to be in this indentation. And this one apparently is just not used. And there's a slight little wear mark here, but I think that's actually from when this was knocked out and the ball was just traveling along there. I guess maybe it scraped it, I don't know. But definitely the little wear mark between this indentation and this indentation is more pronounced. So that also proves that it's not this way that we would want to put this in, because then you see the indentations are way out of whack. This one is too far over. So now I know this goes in this way. So I'm going to do the same thing I did on that one just to make life easier. I'm going to just put a little thin film of grease on there to try and keep it from getting all bound up in there. And this grease, I know some people might be thinking, oh, that grease might react with the oil and create some kind of a horrible thing down the road. Well, it's a very, very small amount of grease I'm dealing with here. This one goes in a lot easier. Tricky getting that to line up just right. It's funny how this one almost seems like it's a little too short for this. Can't go very far before it drops out. Alright. So, some of you may recall that when I took this apart, there were these funky rubber washers, which are the deal that seals these end, where these ends are, that this comes, the threaded ends of those axles, so to speak, comes out. So there's one I haven't taken apart yet, but you can see you get a metal washer on top of this rubber washer. Well, the rubber washer is really deteriorated from age, and it's like really cupped and was crushed in there, and so it's not going to be doing as good a job. So I wanted to replace these, and when I looked at them first, I thought, boy, I remembered having some some weird washers that actually were used for, they were on some screws that were used as on some cheaper brands of hot tubs. They use a system where they screw through a particle board base for a motor mount into a one of those I forget what you call them there. Those, it's got like almost like three nails, and it's got a like a threaded part in the middle, and you bang them into the bottom of the plywood or particle board in this case, and the screw goes down and screws into it. And as you tighten the screw, it pulls it into the wood even further. Well, on the top side, what they do is, on some of them, they have a washer, of course, because you've got that elongated hole in the motor mount. They put these rubber washers to help isolate some of the vibration. They help a little bit, but they don't really do much. But I had a bunch of those, and for some reason I tended to save them when I had extras. I think I finally got around to throwing them out. Unfortunately, they probably would have been perfect for this application. They were probably the correct OD. The hole in the middle would have been smaller, but not by much, and I could always use one of my hole cutters to rectify that problem. But I don't have those. So the next thing I was going to do was I was going to use a piece of inner tube, because I just replaced a flat tire tube on one of the boys' motorcycles. Well, you know, that rubber is so thin. This material is almost, it's kind of like those motor mounts. It's almost plasticized rubber. If I could, you know, if as long as I'm going to make up an adjective. So, and on the back side here, this actually almost looks like a cork material, but I think that's just from age. So anyways, went to the hardware store, found rubber washers, found neoprene washers, and much to my dismay, they were all thinner than this, so I'd have to buy multiple ones, and those aren't cheap these days. And then I'd still have to either double them up, which would give me possibly another leak point where they're touching each other, or at the very least I'd probably have to do like this and put a washer on here. So what I decided I'm going to do, figured, well, if I'm going to do the washer thing anyways, I'm going to fall back on that rubber inner tube because it's free and cheap and I have it. I'm going to cut myself some washers. They're going to be thin, but I'm then going to find myself some metal washers that can, you know, basically cover it better and get that clamping action that I'm looking for. So that's my plan.